Orion Spacecraft. Orion, officially Orion Multi-Purpose Crew Vehicle or Orion MPCV, is a class of partially reusable crewed spacecraft to be used in NASA's Artemis program. The spacecraft consists of a crew module CM space capsule designed by Lockheed Martin and the European service module ESM manufactured by Airbus Defence and Space. Capable of supporting a crew of 6 beyond low Earth orbit, Orion can last up to 21 days undocked and up to 6 months docked. It is equipped with solar panels, an automated docking system, and glass cockpit interfaces modeled after those used in the Boeing 787 Dreamliner. A single J-10 engine provides the spacecraft's primary propulsion, while 8 R-4D-11 engines and 6 pods of custom reaction control system engines developed by Airbus provide the spacecraft's secondary propulsion. Although compatible with other launch vehicles, Orion is primarily intended to launch atop a Space Launch System (SLS) rocket with a Tower Launch Escape system. Orion was originally conceived in the early 2000s by Lockheed Martin as a proposal for the Crew Exploration Vehicle (CV) to be used in NASA's Constellation program. Lockheed Martin's proposal defeated a competing proposal by Northrop Grumman and was selected by NASA in 2006 to be the CV. Originally designed with a service module featuring a new Orion main engine and a pair of circular solar panels, the spacecraft was to be launched atop the Ares I rocket. Following the cancellation of the Constellation program in 2010, Orion was heavily redesigned for use in NASA's Journey to Mars initiative. The SLS replaced the Ares I as Orion's primary launch vehicle, and the service module was replaced with a design based on the European Space Agency's Automated Transfer Vehicle. A development version of Orion's CM was launched in 2014 during Exploration Flight Test -1, while at least 4 test articles have been produced. As of 2020, 3 flight-worthy Orion spacecraft are under construction, with an additional one ordered for use in NASA's Artemis program. The first of these is due to be launched in 2022 on Artemis 1. On November 30, 2020, it was reported that NASA and Lockheed Martin had found a failure with a component in one of the Orion spacecraft's power data units, but NASA later clarified that it does not expect the issue to affect the Artemis 1 launch. Spacecraft Description. Orion uses the same basic configuration as the Apollo Command and Service Module CSM that first took astronauts to the Moon, but with an increased diameter, updated thermal protection system, and a host of other modern technologies. It will be capable of supporting long-duration deep space missions with up to 21 days of active crew time plus 6 months quiescent spacecraft life. During the quiescent period, crew life support would be provided by another module, such as the proposed deep space habitat. The spacecraft's life support, propulsion, thermal protection, and avionics systems can be upgraded as new technologies become available. The Orion spacecraft includes both crew and service modules, a spacecraft adapter, and an emergency launch abort system. The Orion's crew module is larger than Apollo's and can support more crew members for short or long-duration missions. The European service module propels and powers the spacecraft as well as storing oxygen and water for astronauts. Orion relies on solar energy rather than fuel cells, which allow for longer missions. Crew Module CM. The Orion Crew Module CM is a reusable transportation capsule that provides a habitat for the crew, provides storage for consumables and research instruments, and contains the docking port for crew transfers. The crew module is the only part of the spacecraft that returns to Earth after each mission, and is a 57.5-deg truncated cone shape with a blunt spherical aft end, 5.2 meters 16 ft 6 in diameter, and 3.3 meters 10 ft 10 in length. It was manufactured by the Lockheed Martin Corporation at Michoud Assembly Facility in New Orleans. It will have 50% more volume than the Apollo capsule and will carry 4 to 6 astronauts. After extensive study, NASA has selected the Avcoat ablator system for the Orion crew module. Avcoat, which is composed of silica fibers with a resin in a honeycomb made of fiberglass and phenolic resin, was formerly used on the Apollo missions and on the Space Shuttle orbiter for early flights. Orion's CM will use advanced technologies, including glass cockpit digital control systems derived from those of the Boeing 787, an auto-dock feature, like those of Progress, the automated transfer vehicle, and Dragon 2, with provision for the flight crew to take over in an emergency. Prior U.S. spacecraft have all been docked by the crew. Improved waste management facilities, with a miniature camping-style toilet and the unisex relief tube used on the Space Shuttle. A nitrogen/oxygen into/aqua mixed atmosphere at either sea level 101.3 kPa or 14.69 psi or reduced 55.2, far more advanced computers than on prior crew vehicles. The CM will be built of aluminium-lithium alloy. The reusable recovery parachutes will be based on the parachutes used on both the Apollo spacecraft and the Space Shuttle solid rocket boosters, and will be constructed of Nomex cloth. Water landings will be the exclusive means of recovery for the Orion CM. To allow Orion to mate with other vehicles, it will be equipped with the NASA docking system. The spacecraft will employ a launch escape system LES along with a boost protective cover made of fiberglass to protect the Orion CM from aerodynamic and impact stresses during the first 2+1/2 minutes of ascent. Its designers claim that the MPCV is designed to be 10 times safer during ascent and re-entry than the Space Shuttle. The CM is designed to be refurbished and reused. In addition, all of Orion's component parts have been designed to be as modular as possible, so that between the craft's first test flight in 2014 and its projected Mars voyage in the 2030s, the spacecraft can be upgraded as new technologies become available. As of 2019, the spacecraft atmospheric monitor is planned to be used in the Orion CM. European Service Module ESM. In May 2011, the ESA Director General announced a possible collaboration with NASA to work on a successor to the Automated Transfer Vehicle ATV. On June 21, 2012, Airbus Defence and Space announced that they had been awarded 2 separate studies, each worth EUR 6.5 million, to evaluate the possibilities of using technology and experience gained from ATV and Columbus-related work for future missions. The first looked into the possible construction of a service module, which would be used in tandem with the Orion CM. The second examined the possible production of a versatile multi-purpose orbital vehicle. On November 21, 2012, the ESA decided to develop an ATV-derived service module for Orion. The service module is being manufactured by Airbus Defence and Space in Bremen, Germany. NASA announced on January 16, 2013, that the ESA service module will first fly on Artemis 1, the debut launch of the Space Launch System. Testing of the European service module began in February 2016 at the Space Power Facility. On February 16, 2017, a EUR 200 contract was signed between Airbus and the European Space Agency for the production of a second European service module for use on the first crewed Orion flight, Artemis 2. On 26 October 2018, the first unit for Artemis 1 was assembled in full at Airbus Defence and Space's factory in Bremen. Launch abort system loss. In the event of an emergency on the launch pad or during ascent, a launch abort system loss will separate the crew module from the launch vehicle using 3 solid rocket motors, an abort motor AIM, an attitude control motor ACM, and a jettison motor JM. The AIM provides the thrust needed to accelerate the capsule, while the ACM is used to point the AIM, and the jettison motor separates the loss from the crew capsule. On July 10, 2007, Orbital Sciences, the prime contractor for the loss, awarded Alliant Tech Systems ATK $62.05 million subcontract to design, develop, produce, test, and deliver the launch abort motor, which uses a reverse flow design. On July 9, 2008, NASA announced that ATK had completed construction of a vertical test stand at a facility in Promontory, Utah to test launch abort motors for the Orion spacecraft. Another longtime space motor contractor, Aerojet, was awarded the jettison motor design and development contract for the loss. As of September 2008, Aerojet has, along with team members Orbital Sciences, Lockheed Martin, and NASA, successfully demonstrated 2 full-scale test firings of the jettison motor. This motor is used on every flight, as it pulls the lost tower away from the vehicle after both a successful launch and a launch abort. History. The Orion MPCV was announced by NASA on May 24, 2011. Its design is based on the Crew Exploration Vehicle from the cancelled Constellation program, which had been a 2006 NASA contract award to Lockheed Martin. The command module is being built by Lockheed Martin at the Michoud Assembly Facility, while the Orion Service Module is being built by Airbus Defence and Space with funding from the European Space Agency. The MPCV's first uncrewed test flight, EFT-1, was launched atop a Delta Roman 4 heavy rocket on December 5, 2014, and lasted 4 hours and 24 minutes before landing at its target in the Pacific Ocean. Funding history and planning. Ground test articles, mock-ups, and boilerplates. Space Vehicle Mock-up Facility SVMF in Johnson Space Center includes a full-scale Orion capsule mock-up for astronaut training. MLAS and Orion boilerplate was used in the MLAS test launch. Ares IX, the Orion mass simulator, was used on the Ares IX flight test. Pad Abort 1 and Orion boilerplate was used for the Pad Abort 1 flight test. The loss was fully functional. The boilerplate was recovered. Ascent Abort -2 and Orion boilerplate was used for the Ascent Abort 2 flight test. The loss was fully functional. The boilerplate was discarded. The boilerplate test article BTA underwent splashdown testing at the Langley Research Center. This same test article has been modified to support Orion recovery testing in stationary and underway recovery tests. The BTA contains over 150 sensors to gather data on its test drops. Testing of the 18,000-pound 8,200 kg mock-up ran from July 2011 to January 6, 2012. The ground test article GTA stack, located at Lockheed Martin in Denver, is undergoing vibration testing. It is made up by the Orion Ground Test Vehicle GTV combined with its launch abort system loss. Further testing will see the addition of service module simulator panels and thermal protection system TPS to the GTA stack. The drop test article DTA, also known as the drop test vehicle DTV, underwent test drops at the U.S. Army's Yuma Proving Ground in Arizona from an altitude of 25,000 feet 7,600 m. Testing began in 2007. Drogue chutes deploy around 20,000 and 15,000 feet 6,100 and 4,600 m. Testing of the staged parachutes includes the partial opening and complete failure of one of the 3 main parachutes. With only 2 chutes deployed, the DTA lands at 33 feet per second 10 m/s, the maximum touchdown speed for Orion's design. The drop test program has had several failures in 2007, 2008, and 2010, resulting in new DTV being constructed. The landing parachute set is known as the Capsule Parachute Assembly System CPAS. With all parachutes functional, a landing speed of 17 mph 27 km/h was achieved. A third test vehicle, the PCDT V3, was successfully tested in a drop on April 17, 2012. Variants. Orion Crew Exploration Vehicle CV. The idea for a Crew Exploration Vehicle CV was announced on January 14, 2004, as part of the vision for space exploration after the Space Shuttle Columbia accident. The CV effectively replaced the Conceptual Orbital Space Plane OSB, a proposed replacement for the Space Shuttle. A design competition was held, and the winner was the proposal from a consortium led by Lockheed Martin. It was later named Orion after the stellar constellation and mythical hunter of the same name, and became part of the Constellation program under NASA Administrator Sean O'Keefe. Constellation proposed using the Orion CEV in both crew and cargo variants to support the International Space Station and as a crew vehicle for a return to the Moon. The crew/command module was originally intended to land on solid ground on the U.S. West Coast using airbags, but later changed to ocean splashdown, while a service module was included for life support and propulsion. With a diameter of 5 meters 16 ft5 in as opposed to 3.9 meters 12 ft10 in, the Orion CV would have provided 2.5 times greater volume than the Apollo CM. The service module was originally planned to use liquid methane LCH4 as its fuel, but switched to hypergolic propellants due to the infancy of oxygen/methane-powered rocket technologies and the goal of launching the Orion CEV by 2012. The Orion CEV was to be launched on the Ares I rocket to low Earth orbit, where it would rendezvous with the Altair lunar lander launched on a heavy-lift Ares V launch vehicle for lunar missions. Environmental testing. NASA performed environmental testing of Orion from 2007 to 2011 at the Glenn Research Center Plumbrook Station in Sandusky, Ohio. The center's space power facility is the world's largest thermal vacuum chamber. Launch abort system loss testing. Splashdown recovery testing. In 2009, during the Constellation phase of the program, the post-landing Orion recovery test port was designed to determine and evaluate methods of crew rescue and what kind of motions the astronaut crew could expect after landing, including conditions outside the capsule for the recovery team. The evaluation process supported NASA's design of landing recovery operations, including equipment, ship, and crew needs. The port test used a full-scale boilerplate mock-up of NASA's Orion crew module and was tested in water under simulated and real weather conditions. Tests began March 23, 2009, with a Navy-built 18,000-pound 8,200 kg boilerplate in a test pool. Full sea testing ran April 6/30, 2009, at various locations off the coast of NASA's Kennedy Space Center with media coverage. Cancellation of Constellation program. On May 7, 2009, the Obama administration enlisted the Augustine Commission to perform a full independent review of the ongoing NASA space exploration program. The commission found the then current Constellation program to be woefully under-budgeted with significant cost overruns, behind schedule by 4 years or more in several essential components, and unlikely to be capable of meeting any of its scheduled goals. As a consequence, the Commission recommended a significant reallocation of goals and resources. As one of the many outcomes based on these recommendations, on October 11, 2010, the Constellation program was cancelled, ending development of the Altair Ares I and Ares V. The Orion Crew Exploration Vehicle survived the cancellation and was transferred to be launched on the Space Launch System. Orion Multi-Purpose Crew Vehicle MPCV, PCV. The Orion development program was restructured from 3 different versions of the Orion capsule, each for a different task, to the development of the MPCV as a single version capable of performing multiple tasks. On December 5, 2014, a developmental Orion spacecraft was successfully launched into space and retrieved at sea after splashdown on the Exploration Flight Test -1 EFT-1. Orion splashdown recovery testing. Before EFT-1 in December 2014, several preparatory vehicle recovery tests were performed, which continued the crawl, walk, run approach established by port. The crawl phase was performed August 12-16, 2013, with the stationary recovery test SRT. The stationary recovery test demonstrated the recovery hardware and techniques that were to be employed for the recovery of the Orion crew module in the protected waters of Naval Station Norfolk utilizing the LPDME. The walk and run phases were performed with the Underway Recovery Test URT, also utilizing an LPD-17 class ship. The URT was performed in more realistic sea conditions off the coast of California in early 2014 to prepare the U.S. Navy/NASA team for recovering the Exploration Flight Test-1 EFT-1A. The URT tests completed the pre-launch test phase of the Orion recovery system. Orion Light. History. Orion Light is an unofficial name used in the media for a lightweight crew capsule proposed by Bigelow Aerospace in collaboration with Lockheed Martin. It was to be based on the Orion spacecraft that Lockheed Martin was developing for NASA. It would be a lighter, less capable, and cheaper version of the full Orion. The intention of designing Orion Light would be to provide a stripped-down version of the Orion. Bigelow had begun working with Lockheed Martin in 2004. A few years later, Bigelow signed a $1 million contract to develop an Orion mock-up. The proposed collaboration between Bigelow and Lockheed Martin on the Orion Light spacecraft has ended. Bigelow began work with Boeing on a similar capsule, the CST-100, which has no Orion heritage, and was selected under NASA's Commercial Crew Development CC-DEV program to transport crew to the ISS. Design. Orion Light's primary mission would be to transport crew to the International Space Station or to private space stations such as the planned B-330 from Bigelow Aerospace. While Orion Light would have the same exterior dimensions as the Orion, there would be no need for the deep space infrastructure present in the Orion configuration. As such, the Orion Light would be able to support larger crews of around 7 people as the result of greater habitable interior volume and the reduced weight of equipment needed to support an exclusively low Earth orbit configuration. Recovery. In order to reduce the weight of Orion Light, the more durable heat shield of the Orion would be replaced with a lighter weight heat shield designed to support the lower temperatures of Earth atmospheric re-entry from low Earth orbit. Additionally, the current proposal calls for a mid-air retrieval, wherein another aircraft captures the descending Orion Light module. To date, such a retrieval method has not been employed for crewed spacecraft, although it has been used with satellites. Flights. MLAS. MLAS was a test flight of the MAX launch abort system MLAS. Ares IX. Ares IX was a test flight of the Ares rocket. It was launched in 2009 shortly after the program was cancelled. Pad Abort-1. Pad Abort-1 P-1 was a flight test of the Orion launch abort system loss. Exploration Flight Test-1. At 7:05 a.m. EST on December 5, 2014, the Orion capsule was launched atop a Delta Roman 4 Heavy rocket for its first test flight and splashed down in the Pacific Ocean about 4.5 hours later. Although it was not crewed, the two-orbit flight was NASA's first launch of a human-rated vehicle since the retirement of the Space Shuttle fleet in 2011. Orion reached an altitude of 3,600 mi 5,800 km and speeds of up to 20,000 mph 8,900 m/s on a flight that tested Orion's heat shield, parachutes, jettisoning components, and onboard computers. Orion was recovered by USS Anchorage and brought to San Diego, California, for its return to Kennedy Space Center in Florida. Ascent Abort-2. Ascent Abort-2 A-2 was a test of the launch abort system loss of NASA's Orion spacecraft. The test followed Orion's Pad Abort-1 test in 2010 and Exploration Flight Test-1 in 2014, in which the capsule first flew in space. It precedes an uncrewed flight of Orion around the Moon as the Artemis 1 mission and paves the way for human use of Orion in subsequent missions of the Artemis program. The test flight, which had been subject to several delays during Orion development, took place on July 2, 2019 at 7:00 local time 11:00 UTC. The flight was successful, and the launch abort system performed as designed. Cancelled asteroid redirect mission. The asteroid redirect mission ARM, also known as the Asteroid Retrieval and Utilization ARU mission, and the Asteroid Initiative. The Asteroid Retrieval Robotic Mission M spacecraft would rendezvous with a large near-Earth asteroid and use robotic arms with anchoring grippers to retrieve a 4-meter boulder from the asteroid. A secondary objective was to develop the required technology to bring a small near-Earth asteroid into lunar orbit. The asteroid was a bonus. There, it could be analyzed by the crew of the Orion EM-5 or EM-6 Arkham mission in 2026. Upcoming missions. As of 2021, all Orion missions will be launched on the Space Launch System from Kennedy Space Center Launch Complex 39B. All full-scale flights will be into deep space, with the first uncrewed flight, Artemis 1, entering a lunar orbit and the first crewed flight, Artemis 2, going on a lunar flyby. Artemis 1 is scheduled to launch no earlier than February 2022. Proposed? A proposal curated by William H. Gerstenmayer before his 10 July 2019 reassignment suggests 4 launches: the crewed Orion spacecraft and logistical modules aboard the SLS Block 1B to the Gateway between 2024 and 20. The crewed Artemis 4 through 7 would launch yearly between 2025 and 2028, testing in situ resource utilization and nuclear power on the lunar surface with a partially reusable lander. Artemis 7 would deliver in 2028 a crew of 4 astronauts to a surface lunar outpost known as the Lunar Surface Asset. The Lunar Surface Asset would be launched by an undetermined launcher and would be used for extended crewed lunar surface missions. Another repair mission to the Hubble Space Telescope is also possible. Potential Mars missions. The Orion capsule is designed to support future missions to send astronauts to Mars, probably to take place in the 2030s. Since the Orion capsule provides only about 2.25 M379 QFT of living space per crew member, the use of an additional deep space habitat module featuring propulsion will be needed for long-duration missions. The complete spacecraft stack is known as the Deep Space Transport. The habitat module will provide additional space and supplies, as well as facilitate spacecraft maintenance, mission communications, exercise, training, and personal recreation. Some concepts for DSH modules would provide approximately 70.0 M32472 QFT of living space per crew member, though the DSH module is in its early conceptual stage. DSH sizes and configurations may vary slightly depending on crew and mission needs. The mission may launch in the mid-2030s or late-2030s. List of vehicles.